Hi friends, welcome to follow up. Let's have a look at problem 2433. Find the original array of prefix exclusive OR. So in this video, we are going to practice some basic properties of exclusive OR. So notice that this is a bitwise operation, right? So first, let's digest the problem statement. So here we are given an integer array called pref. So of size n, we want to find the original array of size n that satisfies the following condition. So prefix I is a exclusive OR up to index I for these numbers, right? So we want to find this original array. So that's our target. So here we have two examples. The second example is very special, right? Basically, it covers the I equals 0 case in the main statement. If I equals 0, so the prefix I, prefix 0 equals the first number in the original array. So that's example 2. So similar, you can see it from the first example. We start from 5 for the pref, and also in the array, it's also start from 5. And then it gets this corresponding numbers. So here the constraints are the following. First, the prefix array has values bounded below by 1, and everything not the value. So the length is bounded below by 1 and bounded above by 10 to the power 5, and the elements is non-negative. So with that said, we are ready to do the analysis. So here, actually, this problem is a very straightforward problem. Strategy XOR property, right? So let's first recall what's XOR. So this is a bitwise operation. For example, if in the corresponding bit position you have 1, then 1 exclusive 1, it's going to get 0. And also 0 exclusive 0 for sure will be 0. And then you get 1 exclusive with 0 equals 0 exclusive with 1, that is 1. So in other words, if the two operands are the same, so we're going to get 0. If they are different, we're going to get 1. So this operation, or exclusive OR, is commutative, right? So it's actually also associative. You can verify that. So for this problem, first we know pref I. Let's write this as array. Let's write this as a, right? Pref the original array corresponding to a. It will be something like this: a1, then up to ai, right? So first observation is that if you use I equals 0, so you get pref 0 equals a naught, right? A0. This is the one thing. So now we also observe this one. If we consider prefix I minus 1, so what we are going to get is a naught up to a1, then up to ai minus 1, then up to ai. So notice that due to this property of the for the exclusive OR, for integer we are going to get a exclusive a itself is going to be 0, right? Because if a and a have the same binary representation, in the corresponding positions, bit positions, for sure the digits are the same, so they are going to get 0. Then if we can use this, let's call it cancellation property, right? So we can use this cancellation property. Then we're going to get pref I, so exclusive OR with pref I minus 1. So we're going to get this exclusive with this. So notice that exclusive OR is commutative, right? We can cancel this 2, cancel this 2, a naught, and cancel ai minus 1, ai minus 1. So here, we should stop here, right? So we are going to have something like this, I minus 1, then exclusive with I, right? This is better to visualize the final result. This will give us a I, right? So this is what we are going to do. So what we want to do, let's see, we can write, we can get the length of this pref, and then we can initialize a result that is 0 times n, right? So result at 0 will be pref 0. And then we can set the other values. So for I in range, so starting from 1, right? And then ending at n-1. So what we want to set, result I will be pref I exclusive OR with pref I minus 1. So this way we finish setting the result, and then we can do the return. So this is the one way, very robust to solve this problem. But before we improve this a little bit better, so let's do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the cases. So here, one optimization is that we can improve the space complexity to be to just do in place. So let's see, we do in place operations, right? So for this, what we can do, so we know that for the first element in the result, it's just the number exclusive OR with 0, right? Because here we also have another property, A exclusive 0 is 0 for any A, right? Because 0 has a binary representation zeros. So, right, so you know if you have 0, so you just get the other party in the result. So now for what we want to do, we can use a current equals 0. And then what we want to do for I in range, say, length of preference, right? We want to set all the elements. So for now, first let's save using a temporary variable, the current value, that is prefix I. Because next round, this prefix I will be serving as prefix I minus 1, right? So what do we want to do? And we want to do prefix I. So this is the current one. So we just do exclusive OR with the previous one. So previous one, if I equals 0, we need to do it with 0. So it's current. And then in the next round, we are going to set the current to be prefix I, right? So we are going to set current equals temp. Because here we rewrite, overwrite this prefix I. That's why we first use a temporary variable to save it. So this temporary variable you can think of as the original prefix I. Then in the next round for I plus 1, so we are going to do prefix at I plus 1, then exclusive OR with prefix I. Then we're going to get the result at I minus 1, right? This is the logic. So we are going to return this variable. So this is another solution, but we do in-place operations. So before we make some comments, let's do a test. Yeah, it passes one example. Now let's look at the generic case. Why it's so slow? Oh, I guess we didn't change the function signature. So here I might change this to be v1. So now we are going to check this one, right? So now let's do a test. Submit. Yeah, it passes all the cases. So with that said, basically that's about it for this specific problem. So I would say that the application of exclusive OR operations can be very important, can be very useful. So there are a large number of leetcode problems which involves using the properties of exclusive OR. You can actually check out those problems, or you can practice and share some more examples. Yeah. So with that said, I guess that's it for this video. Thank you.